Right. So what did we look at? Well, we started off, I did the intro video earlier on, and what we then looked at was a dot cross diagram. So we've come across these before. So this is a dot cross diagram of something called methane. And I was just introducing and showing that carbon has 4 bonds. So when you redraw that as a displayed formula, otherwise known as a stick diagram, you can draw these bonds as little sticks. And hydrogen only has 1 bond, so you would this a very maybe the simplest, probably the simplest organic molecule would be methane. And you can then I talked about these other types of drawing. So that would be a molecular formula, displayed formula. I'm not sure what this is called really. And then I just introduced you can actually make these at school, or well, if you buy them yourself, called something called molymods. I talked about the name of something made out of only hydrogen and carbon is called a hydrocarbon. All right. And then we looked at some ways of making different hydrocarbons. First with single bonds and different numbers of hydrogen atoms. So I made the first one, methane. Now I'm going to also tell you the names of these other molecules as we go along. So this one is called ethane. Notice the ending is the same, but the beginning is different. This one is called propane. And the last one is called butane. So let's use a different color to underline the one that's similar. So the ane is the same, right? And the thing that's different is the bute, and the bute, the prop, and the eth, and also the meth and methane. So so that bit there, that tells you the number of carbon atoms. Okay, so if we went down to the other molecules that we drew afterwards, the ones with double bonds, then the double bond, the 2 carbons on the previous one began with eth. So this is going to begin with eth as well. So this is eth, but this time it's ethene. And this would begin with prop. And of course, it's propene. This is the sort of language bit that comes into it when you feel like you're learning a language. And each part of the word means something different. And this would be called butene. So again, the ending, this time it would mean, well, it's this kind of molecule. And this has a general name for these kinds of molecules as well. And we already learned from the first bit that the eth, the prop, the bute is just how many carbons it's got. So what is the general name for this type of molecule we've got here? Let's use maybe blue, blue. These are called alkenes. And you might have guessed what the one above is called. And I'm going to have to write it quite small, unfortunately. It's called alkanes. So alkanes have only single bonds and alkenes have double bonds. Okay. Other than that, they're very, very similar. Well, almost identical. They do have different properties. The actual chemicals behave in a different way, but when it comes to drawing them, that's the only difference. Obviously, so that's it. So a chain of carbon molecules with these different numbers of, one single. You only want to draw 1 double bond. You could, in theory, draw 2 double bonds, but we're not going to bother with that at this point. We also talked about these different, for each one, alkanes and alkenes. We talked about the different formula like this. So we're just counting them up: C2H6, C3H8, C4H10, and that would be the molecular formula, which I talked about, and then the displayed formula. No, sorry, not the displayed formula. I've misnamed that. That should say structural formula. Sorry, structural formula. The displayed formula is a dot cross diagram. The structural formula is showing you basically just how it's structured. So CH3, 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 and so on, right? CH3, CH2, CH3. So it just groups them up as you go along the spine of it. Looking at the molecular formula, you can see that this, then we can work out a general formula. This one's a lot harder to see, but after a little bit of studying, you notice that it follows that pattern. For whatever amount of carbons there are going to be 2 times that amount plus 2 hydrogens. So by looking at these, you'll notice it follows that formula. Down here, it's a lot easier to notice. It's simply the hydrogens are double the carbons. So CnH2n. That's the general formula for alkenes. The previous one was the general formula for alkanes. So that is all we've touched upon so far. I think I've covered everything. Was that everything? I think I've sped through everything. Is that everything we need to cover? Did we talk about anything else in that lesson? And the only other thing I guess I didn't really mention in that little video was in this little video is these bonds. So I can show the electrons being shared here, and that would be redrawn as this in the structure in the displayed formula or the stick diagram, and this is being shared twice. So 2 pairs of electrons being shared, and it would be drawn as that. Now, this is an inaccurate diagram. This is showing me, according to this diagram, each carbon only has 1 electron, which is obviously not true, but I'm just demonstrating it to show how the bonds are drawn. Okay, right.